Today we will take a wonderful journey through the history of programming. A journey that will cover the evolution and development of programming languages, from ancient algorithms to modern technologies. Programming, an integral part of the current world, has continued to attract the attention of scientists, engineers, researchers, and enthusiasts for many years because it is through programming that we bring our ideas to life, create new technologies, and change the world around us. This documentary will take you a wonderful journey through time and technology, telling you about the difficulties that geniuses of the past overcame to create the programming languages that we use today. We will delve into the history of algorithms, computers, and the individuals whose ideas and hard work have left an incredible mark on the world of computing. We will go from the elementary mechanical devices for automating calculations to the creation of high-level programming languages and the integration of artificial intelligence into our daily lives. Get ready to dive into the amazing world of programming, a world where every line of code opens up new possibilities. Welcome to the history of programming languages. The history of programming goes back to ancient times when people began creating methods to automate calculations. One of the earliest examples is the use of abacus, which was invented about 3,000 years ago and was used to perform arithmetic operations. With the development of mathematics and science, the issues of automating calculations became more and more important. In the 17th to 18th centuries, mechanical devices appeared, such as slide roulette and mechanical calculators designed to perform mathematical operations. The famous mathematician and engineer Charles Babbage in the middle of the 19th century developed the project Analytical Engine, a harbinger of a modern computer. Charles Babbage's Analytical Engine, conceived in the 19th century, is considered a precursor to modern computers. It was an ambitious mechanical device designed to perform any mathematical calculation. The engine featured an arithmetic logic unit, control flow through conditional branching and loops, and memory storage, embodying many elements of today's computers. Although it was never completed in his lifetime, Babbage's design laid foundational concepts for computer science. However, a real breakthrough in the history of programming occurred in the middle of the 20th century with the invention of electronic computers. The first programs were written on machines and assemblers, which required direct interaction with programmers with the computer hardware. In the 1950s, the first high-level programming languages appeared, such as Fortran and Lisp. These languages provided programmers with abstract tools for describing algorithms without being tied to specific hardware. In the following decades, new programming languages emerged, each aimed at solving specific tasks and problems. Among them, C, developed in the early 1970s, became the basis for many other languages, including C, Java, and Python. With the development of computing technology and the evolution of market requirements, other programming paradigms such as object-oriented programming, functional programming, and parallel programming have emerged. Today, we see the emergence of new programming languages, as well as the development of technologies such as artificial intelligence, machine learning, blockchain, and the Internet of Things, which continue to shape and change the history of programming. Alan Turing, a remarkable mathematician, logician, cryptographer, and computer science pioneer, has left an incredible mark on the history of modern science. Born in 1912 in the United Kingdom, Turing showed amazing abilities in mathematics from an early age. His most famous contribution to the field of computer science is related to the creation of the concept of the universal Turing machine. In 1936, he published his article on computable numbers with a Turing machine, where he proposed a model of a theoretical machine capable of performing every calculation that can be performed with an algorithm. The Turing machine became a basic concept in the theory of calculations and became the basis for the formal definition of an algorithm. This concept has a fundamental value in computer science and is at the heart of all modern computers and software. During World War II, Turing played a main role in solving the code of the German encryption machine Enigma. His work to encrypt and decrypt messages is regarded as revolutionary and contributed to the victory of British and American intelligence during the war. The first programming languages laid the foundation for modern computer programming and made it available to a wide range of users. Here is a brief overview of the first two programming languages, Fortran and COBOL. Fortran was developed in the 1950s by a team led by John Backus at IBM. This language was specially designed for scientific and engineering calculations. Fortran was the first high-level programming language that allowed programmers to write code at a level of abstract math than machine code or assembler. This has made programming more accessible and understandable for specialists in the field of science and engineering. Fortran has become the basis for many other programming languages and is still used in some areas of scientific and engineering calculations. COBOL was developed in 1959 by a team under the leadership of Grace Hopper and was intended for business applications. COBOL was the first programming language specially designed for processing business data and automation of business processes. It was founded in the English language, which made it more understandable for business analysts and managers who do not have a technical education. COBOL quickly became widespread and is still used in many enterprise systems, especially in the financial industry. Fortran and COBOL paved the way for the development of programming languages and gave rise to the evolution of computer programming, making it more affordable and easy for various areas of application. The computer revolution is a period of intensive technological development, which began in the middle of the 20th century and is still developing, introducing important changes to society, economics, culture, and our lifestyle. This period is characterized by the fast development and integration of computers and digital technologies into many aspects of human activity. The development of personal computers came about through some events and innovations that notably influenced programming and modern information technology. Here are a few important events and their influence. Invention of the microprocessor. In the mid-1970s, the invention of the microprocessor opened a new era of personal computers. Microprocessors, such as Intel 4004 and Intel 8008, became available for wide consumers and allowed the creation of compact and relatively inexpensive computers. Introduction of the first personal computers. In the late 1970s and early 1980s, the company, such as Apple, IBM, and Commodore, presented the first mass personal computers, such as Apple II, IBM PC, and Commodore PET. These computers have become available to a wide audience and stimulated interest in programming. The appearance of operating systems with a graphic interface. In the 1980s, operating systems with graphic interfaces appeared, such as Apple Macintosh system and Microsoft Windows. These interfaces made computers more friendly for users and simplified the development of programs. The Internet and the development of network technologies. In the 1990s, the spread of the Internet led to the emergence of network applications and web technologies. This created new opportunities for programmers and contributed to the growth of the need for web development and network programming specialists. The free software movement. Free software, such as Linux, Apache, MySQL, and PHP LAMP, has created new opportunities for cooperation and development of software. It also influenced the programming culture, stimulating the exchange of knowledge and open access to resources. Overall, the development of personal computers significantly influenced programming, making it more affordable and widespread. The appearance of personal computers has opened up new opportunities for innovation and creating software, and over time continues to form modern information technology. The Internet and virtual worlds are an exciting world of technological achievements, which has significantly changed our communication, work, and entertainment. Here is a brief overview of the evolution of the Internet and the emergence of virtual worlds. In the late 1960s, American explorer Leonard Kleinrock proposed the concept of package switching of data, which became the basis for the development of the ARPANET network, created in 1969 by the U.S. Department of Defense. ARPANET was the first network to use the TCP/IP protocol, which became the foundation of the modern Internet. However, the revolutionary moment came in 1989, when the British scientist Tim Berners-Lee proposed the concept of the World Wide Web and developed a system of hypertext links, HTTP, the language of hypertext marking, HTML, and the first web browser. This allowed users to exchange information and create related documents by providing the basis for the development of websites and virtual worlds. The first websites appeared in the early S, mainly in the form of static pages with text and images. Over time, websites have become more interactive and dynamic due to the development of programming and technology languages, such as JavaScript, CSS, and server programming languages. Simultaneously with the development of the Internet, virtual worlds began to appear online platforms that provide users with the possibility of interacting in virtual environments. With the advent of more powerful computers and faster internet connections in the 2000s, virtual worlds became more realistic and large-scale. Game worlds, such as World of Warcraft, have become widespread, and social networks have become virtual platforms for communication and interaction. Today, the Internet and virtual worlds have become an integral part of our daily lives, providing us with the opportunity to communicate, work, have fun, and even study in a virtual environment. Their constant development and innovation proceed to expand the capabilities and appeal of this unique world of technology. Modern programming languages play an important role in various fields of software development, from web development and mobile applications, ending with data analysis and artificial intelligence research. Let's look at several of them and their use in various areas. Python. Designed in the 1990s by Guido van Rossum, Python is widely used in web development, scientific research and data analysis, machine learning and artificial intelligence, as well as in the automation of tasks and the development of scripts. Python is known for its simplicity, readability, and powerful libraries, which makes it one of the most famous programming languages in the world. Java, created in 1996 by James Gosling and his team in Sun Microsystems. Java is a universal programming language used to create various types of applications, including desktop applications, mobile applications, Android, web applications, and corporate applications. Java is distinguished by its cross-platform reliability and scalability, which makes it a famous choice for the development of large projects. JavaScript, written in 1995 by Brendan Eich. JavaScript is the main programming language for web development, ensuring the interactivity and dynamic behavior of web pages. It is also used in the front-end development of web applications, as well as on the back-end using Node.js. JavaScript is famous due to its versatility, wide application, and active ecosystem of libraries and frameworks. PHP, written in 1994 by Rasmus Lerdorf. PHP is one of the main programming languages for creating dynamic web pages and web applications. It is widely used in the development of online stores, social networks, blogs, and other web applications. PHP attracts developers with its simplicity, accessibility, and wide spectrum of web frames. Perl is a programming language created by Larry Wallow in the 1980s. Perl is famous for its powerful opportunities for working with text, regular expressions, strong support for working with files and text flows, built-in modules for working with networks, databases, and multitasking. Applied in web development, processing of requests, systemic administration, processing texts and logs, in working with databases. These programming languages have different features and applications, which makes them important tools for developing various types of software. Artificial intelligence is a field of science that deals with the creation of systems that can perform tasks that require human intelligence. From speech recognition to autonomous cars, artificial intelligence has become an integral part of our lives. The roots of artificial intelligence go back to the mid-20th century, when scientists began developing the first algorithms and models. In 1956, the purpose of artificial intelligence was formulated at a conference in Dartmouth, and after that, this field began to develop fast. Nowadays, artificial intelligence covers many technologies: machine learning, neural networks, and natural language processing. These tools help analyze huge amounts of data, find patterns, and make predictions. Artificial intelligence is used in various fields, from medicine and education to transportation and art. It helps doctors with diseases, improves educational platforms, and optimizes logistics. In the last few years, artificial intelligence has become an integral part of our lives. Chatbots and AI image creators are two exciting areas where artificial intelligence demonstrates its capabilities. Chatbots are computer programs that can talk with users, answer questions, offer support, and entertain them, allowing humans to interact with digital devices as if they were communicating with a real person. Chatbots as rudimentary programs that answer a simple query with a single-line response, or as sophisticated as digital assistants that learn and evolve to deliver increasing levels of personalization as they gather and process information. AI image creators are like chatbots, but they create images and videos using generative artificial intelligence algorithms. These technologies can generate realistic photographs, artwork, or videos based on text queries or existing images. AI image creators and chatbots promise new ways of design, advertising, programming, and entertainment, allowing users to visualize what did not exist previously. With the rise of chatbots and AI image creators, essential ethical questions arise. How can we provide transparency in the use of artificial intelligence? How can we protect copyrights and prevent abuse, security, privacy, and algorithmic bias? society must think about how to use artificial intelligence responsibly and ethically. Artificial intelligence will continue to evolve, promising discoveries and solutions to complex problems. However, it is important to remember the balance between ethics and responsibility. The future programming promises exciting challenges and opportunities that will continue to expand the vision of technology and transform our world. In this context, it is worth seeing two key areas that gain more and more importance and influence: quantum computing and bioinformatics. Quantum computing is a promising area that promises to revolutionize the processing of information. Unlike classic computers, quantum computers use quantum bits or qubes, which can be in a state of superposition and conduct quantum operations. This allows quantum computers to solve certain problems much faster than classic computers. However, the development of this area also encounters challenges such as the complexity of algorithms and the need to develop new programming methods for working with quantum systems. Bioinformatics is a synthesis of biology and computer science aimed at solving biological problems using calculation methods. The possibilities of bioinformatics include the research of genomes, the prediction of the structure of proteins, the modeling of biological systems, and much more. Programmers working in this area should have deep knowledge of biology and computational methods to effectively solve complex biological problems using software. In the future, programmers working in the field of quantum calculations will face the task of developing and optimizing algorithms for quantum computers, as well as the creation of new programming tools specially adapted for working with quantum systems. On the other hand, programmers engaged in bioinformatics will continue to develop innovative methods for analyzing biological data and modeling living systems. So, future programming promises wonderful challenges and opportunities in the field of quantum computing and bioinformatics, which will allow programmers to expand their skills and make a significant contribution to science and technology.